Hello and welcome to day 3 of the How to Get Started with Solana Development in 2026 series. Today we're gonna write our first Solana program, and in the process we're gonna better understand how transactions really work. We're gonna discuss the concept of account ownership, and we'll understand that all state on Solana is stored in accounts, or everything is an account. We will be working with Anchor, which is a framework for writing Solana programs. Anchor will be released in version 1 soon, but I will have separate videos on that. For what we're doing today, not a lot is going to change with the new major version, so I think it's fine if I still do it with the old Anchor. Yeah, we will repeat a few things that we learned yesterday, but in case you haven't been around yesterday, obviously you want to make sure that you understand the concepts of yesterday's video before continuing here, otherwise it might get confusing. Or not. Feel free to just watch this again. I'm not your mom, I'm not telling you what to do. But in case you feel lost and you don't know what an account or an instruction or a transaction is, maybe go watch yesterday's video. Okay, let's go get started with our first little program. As mentioned, I'm gonna use Anchor in version 0.32, and to create an Anchor project, you just type Anchor init and give it a name. This is the most difficult part because I'm always not creative. Anchor program, not creative. And then it will download and install all of the dependencies that it needs. And voila, we'll have the Anchor program folder here. The interesting parts are the Anchor TOML and the actual program that lives in programs source librs. That is the actual program code. And you see it comes pre-filled in with a template of a simple Anchor program that has one function initialize. We also call that an instruction. But as mentioned yesterday, this naming can be confusing because the instruction for me still is the thing that contains the information for which program, which instruction, and what the parameters are. However, that's what this thing defines. It defines the program, it defines the name of the instruction and the parameters that we could put here. Input parameter, I don't know, make it a U8, just some 1 byte as input. If my function would take an input parameter, a simple number, I could just write it here. And all that does is it logs a message saying greetings from the program, and then it says okay. And we could add a second message. The input parameter is this. That's not actually how this works. There we go. Then it will print that number as well. That template is already a finished program that should already work. So I'd say before we implement more, let's already go through the process of deploying a program, which means getting that program on chain. And to do so, we need to go through 2 steps. Number 1, we need to build this program. So compile it from the source code to actual executable machine code. And then we're gonna send that executable to Solana such that it's stored there. And that's what we call deploy. We deploy the program to the chain. We basically upload the executable. And Anchor, that would be Anchor build. Oh, now it's gotta download Anchor stuff first. Okay, fine, sure, why not? Since it's the first time I'm doing this here, we gotta download the new Anchor version. Alright, there we go. Now we compile all of the dependencies here. Anchor does have a lot of dependencies. And then in the end, it will compile our program, which it did. That was quick. And now it still creates an IDL for us. Not so important. Here, there we go. That target was built. And now we should have our program SO file. That's the executable. It's an ELF file, but the details for now are not too important. I do have deep dives on that as well. For us, it's just important that the program was now compiled to this file, and this is what we now need to upload to Solana for the program to exist on chain. And that process of uploading we call deploying. So we anchor deploy. But before we do that, we gotta tell it where to deploy to, because the default uses this key pair and deploys to localnet. I do want to use defnet though. So we're gonna change this to defnet, and that was the key pair that we created in the first video, but I don't think that it has any balance. Nope. So for that to work, I could either change the key pair or I make sure that this address actually has some balance. So there we go. Now we have 5 sol and I can use this. That's perfect. Cool. So back to our anchor deploy. If we're doing this, the program is being sent to the chain that takes a few transactions, but then we get deploy success. So the program was now uploaded to Solana DevNet. And now I want to test this. I want to run this program. But remember, we don't run the program by saying program.run. In order to run a Solana program, what do we have to do? Well, yeah, we have to send a transaction that contains an instruction that calls the program. And Anchor has tests prepared. Add your test here. This one doesn't work out of the box anymore because we're missing something. We have added this input parameter here. So this thing expects the input parameter. I'm just gonna say 1 is the input that we give to this function or method. We can say it's a method. Sure, why not? Let's do object-oriented functions. Anchor calls it methods here. And that's basically Anchor's way to build an instruction and then directly make a transaction and send it to the RPC. We don't need to be too worried about that. That's just the code that exists here. So let's just try and run this. Since it's the Anchor tests, we run it with Anchor test. Oh, and when we do test, it also deploys the program one more time. We could ignore that, but that's fine. So our Anchor program was tested and this is initialized test was run. We get this your transaction signature text here and it gives me the signature. I don't know why it calls it TX. I wouldn't call it TX. I would call it signature, but you know, whatever. I'll call it signature. And we can even look at that in the Explorer on DevNet. Since we deployed to DevNet, this is public on DevNet now. And we see what happens. We have those 2 accounts. One that was my account, my wallet account, the CW, and the CT, that is then the program that was deployed. So here we see this is a program that is being called. Yesterday we had the Manmo program and the system program. Today we have our own program. And we see that from this Anchor program, the initialize function was called. And the input parameter was a U8 and had value 1. And then if we go down to the logs, we see the greeting from our program and the input parameter is 1. So here we have a transaction that had an instruction that was calling our program. And that's how the program was run on Solana. Voila! Done! We wrote the program. Easy. See you tomorrow. Right? Is it that easy? It is that easy. Yeah, I mean, it is that easy. But there's a bit more to understand here. Let's dig a bit deeper. But actually before, just because I personally don't enjoy this, because that always confuses me. I mean, I can give it a nickname, but that makes it big. I like that the Explorer can do that. So now we don't need to remember that. We can just give it a nickname. Does that stay if I refresh? Yeah, cool. Okay, let's leave it like that. Might make it a bit easier. I could, of course, also here use another wallet where it's more obvious. I don't know, I guess it's fine. So far, we're not doing anything. We're logging some stuff, but we're not yet working with accounts. And now we will see that we need to treat accounts differently than other input parameters. Those accounts come through this context, and that context has a type, and that's defined with this struct down here. So if we want this instruction to take accounts as arguments, we can put them in here. And the convention is that you call this struct the same as the function name or the instruction name. Personally, I like to call them the function name plus accounts. Then for me, it's clear that those are the accounts, because that was confusing me in the beginning. What is this part? Oh, those here are the accounts for this instruction. So I'm gonna call them that. The convention is not to do this, but to make it easier for you to understand, we derive accounts. So this struct becomes the accounts for this instruction. So let's put in one account For instance, we want in our instruction to be able to know who sent that transaction. So in our example, the Andy's wallet, for now we have no access to that because that account, even though it was put into that transaction, it's not put into the instruction. Because really it goes the other way around. We have all of the instructions that have accounts, and all of the accounts that the instruction needs will be put in the list of accounts of that transaction, plus the fee payer if that's extra. But yeah, so to get access to that account, I will say, what's the name of it? I give it a name, I call it user, whatever. And to make sure that this is actually not just any account, but one that is a signer, so there's a signature present, meaning that they have the private key for that address. So we use a signer. This can also mean something else, but we're going to discuss that either tomorrow or the day after when we discuss PDAs. But for now, we just assume that this user, they have a private key for that given address. So you need an info, okay. So then I will also need to put this here. This is just something that you need to know. Lifetimes, if you're not used to Rust, just ignore it for now. But basically, we're putting an account, call it user, say it should be a signer. So let's quickly check why this is complaining. Anchor build, client accounts initialize. Oh, because I changed the name, so I also need to change the name here. Ah, yeah, that makes sense. And now, yes, now it builds. Perfect. So I have put this user here, and that's in here, so that context is now aware of this account. So this context in .accounts will have this user. Anchor just does that magic for us, and we can access that account. So we could, for instance, read the public key. So let's also just, this program was called by, and then I let you expand print this key. Let's build that and test that. Test will automatically also deploy it before. And then our test looks like this, is initialized, was successful. That's the transaction. And we can look at it here and scroll down and see that this program was called by, and there we have the public key of Andy's wallet. Isn't that fun? So that's the program, and that's the user calling it. Freaking magic, right? How did that get in there? Magic. Anchor does a lot of magic. That makes it easy to work with in the beginning, but could also lead to issues of you not understanding why something doesn't work. So basically here, this method automatically added accounts, this user, which is optional. If I don't provide this user with a different account, then it will just take my wallet that I defined here in the workspace. But I can define a different one. I could be like user account, could make that a different one to the fee payer. So if I try to put in a different account here for this user account, Anchor will complain because we require this to be a signer. So it needs to sign. I need the private key for that. I could call it a system account, and we'll get to what that means in a second. Then it wouldn't complain here. I just need to build it again and then test. Then this should work. There we go. Now it passed. And here it now says Andy because that's the address that I put in. Because that account was put in here into this instruction. So we also see that account being added to the accounts of that transaction. But it's now not correct anymore. This program was not called by this account. This was just put as an argument. So either I need to change that or put it back to signer. All of that was just to show where that really comes from. It comes from here, except if I don't provide the user, then we'll take my wallet per default. And that's fine for now. So we can use an account in our instruction. That's how we put an account as an argument to our instruction. And anything else I can put in here. I could even put here another user key or a input address and make that a pub key. If I would just be interested in the key, I could put that here as a pub key, but then I really just get the address. So those 32 bytes of the address and not the entire information of the account. So I won't get access to the data. or the Lampert's field of that account. I would just have the address. Maybe that's enough if I just need the address. For us, it would be if I just print it. But as we learned yesterday, we need to put in the accounts up front in the transaction such that the runtime knows what state we touch and therefore how it can execute stuff in parallel in the processing. In the blocks, it's still sequential every transaction, but in the processing steps, they can be run in parallel. So yeah, then it wouldn't be put here. If you really just need to write the address somewhere, you can do it like that. But in most cases, if you want to deal with an account, you really want it as an account and get access to the entire account, so you would put it here. This was just a little excursion that, in case you didn't understand what I meant by that, it doesn't really matter. Okay, now let's actually do something with accounts. Here comes a very important thing that you need to know about Solana programs. Every Solana program is stateless. There is no state stored in the program. And other chains might do that differently. What do I mean by that? That means that my program cannot remember stuff. The program itself cannot remember, oh, last time I was called with this input parameter. The program, as it is deployed on chain, stays the same. It stays constant. Nothing in there changes, and it doesn't have any variables in there that it has, like it doesn't have local variables. There's also no global state. In order for a program to have state, it needs to work with accounts. So if you want to write something, remember some variable or whatever, you need to have a separate account for that. By the way, the same is true for Solana globally. Solana doesn't have global state. All the Solana state is in accounts. That's why we say everything is an account, because even the programs themselves are written to accounts. So technically they are state of Solana, but the programs themselves don't have state. But the deployed programs, they are part of the state of Solana because they are living inside accounts. Specifically for this program, it's living in that account that we have here, our program, an account, a program account with another account that actually contains the executable. So what we're doing when we're deploying the program is basically we're writing to this account the new version of the program, and this program account points there. And with a new loader, it will just be one account because things are changing on Solana. Anyway, where were we? Oh yeah, we were talking about if we want state, which means remember something, then we need to use account. So let's say, as an example, we want to remember what mood my program is in or something like that. So I do an enum for mood. So maybe my program can be sad. Maybe it's happy. Maybe it's annoyed. Maybe it's excited. Maybe it's bored. Alright, that's enough. But the program itself, it can't remember that. I mean, I could hard code one mood in there, but then if I needed to change that mood, I need to redeploy the program with the new mood. Oh, that's, by the way, another interesting thing to note. Programs on Solana per default are upgradable. So you can redeploy them with a new version until you say, I want to make it immutable, and you throw away the upgrade authority. We'll get to talk about the authorities in a few days. But for now, let's stay with this example with the moods. And I just want to deploy my program once, and then I should be able to change the mood. So I want to have a function to set mood. Well, actually, we're in Rust. That's how we spell it. So that again, we'll take a context and a new mood, which gonna be a mood, and the rest similar to this. We just say new mood and we print that mood, except that won't work because I need to tell you that you have a derive debug or perfect. It already suggests that. Then I can print it like that. Multiple definitions of the, okay, you can't serialize that. Okay, maybe then I need to tell you to make this a U8. So this enum should be represented as a U8. Represent this as U8. Does that fix it? Nope. That's annoying, but as a U8 it would work. Yeah, Fine, I'll just keep it a U8 and then I just implement a function like this where I can get it from a U8. I implement for the mood a from U8 and then I just say here mood from U8, new mood. There we go. Okay, that still just prints it though. In order to actually save it, I need an account that I can save it into. Because as we said, the program, we can't have a global variable here that we can change throughout program executions. That doesn't work. Something like program's mood it's sad because it can only have that mood. I can do that, but then it's a const. And I can do a const, but that never changes. I cannot have this be a variable. Cannot assign to immutable static item. Immutable. We cannot change this. If I make it mutable, use of mutable static is unsafe and requires unsafe function. Point is, you shouldn't even do this. Don't even try because that's not how you can do it anyway. I was just giving that as a mental thing. We need an actual account to store stuff. So let's make a separate one of these for the set mood accounts. And this will just take the state. I'll call it state. And in Anchor, I can define what type of account this should be. This is done with this account macro, and then I give this a struct. Let's call it mood account. So this is how one of those accounts should look like, what it should store. Basically, here I put in the variables that I want to have in state. And basically what I want to store is the mood. So mood, do I store that as a U8? Can I store the mood or will you complain here? You will complain here. It's just a problem with the serialization. What if I just tell you that Borscht serialize and Borscht deserialize you can do, and then we don't even need this? Could I then do that? And now you still need clone. Okay, fine. I can also derive clone. It's literally a U8. You can clone that. There we go. Then that works. Then I can also put that here as a mood. And then I don't need to go through that weird option here with that implementation. Perfect. Now we work with mood directly. We just need to tell it how it can serialize and deserialize that. Again, details, not that important. We will talk more about serialization and deserialization on day 6. Okay. So now that we have the account defined, what should be stored in there, the mood, then we need to tell, oh, this state account is of type mood and also lifetime. The mood account, of course, not the enum, the account that we defined down here, we need to say, yeah, that works. So my state account is of type mood account and a mood account has stored a mood. That's what we want. So this state account, I should now have access to in here through this context accounts. Oops, no I don't, because here I also still have the wrong one. Yep, now I have the state and here I can access this mood. So now I can just say, hey, the mood is now this new mood. And that's all I need to do to update the state of that account. Or the mood field. The state might be a bad word for this. So this is the account. State account, mood account, data account, whatever you might call that. That account has data, and as part of the data it has the mood, and the mood is what we change. Okay, so far so good. Mood is more private. Well, make it public then, not like I care. Okay, now with this, we should be able to change the mood. Except we didn't really discuss what this account really is, right? Like what do we put in there? Because let's do a test. Let's do another one of these. Like set mood, and we call the method with the, wait, hold on, for this to work I gotta first once build it. Oh no, it doesn't build. Why does it not build? Oh, I think that's just the IDL, but I need the IDL as well. Maybe I should do it with a U8 then to not annoy the IDL. Okay, it doesn't like that I use this mood. Okay, then I just use this internally, and externally I use U8s. So the mood account will store a U8 and the input will take a U8. Then hopefully my build will work. Yeah, then it can also do the IDL. Okay, perfect. What I'm fixing now is this IDL. So that's a representation of my program in JSON format, and it has all of my instructions where it also contains the parameters and what type they are. And here it complained that it didn't know the mood. So yeah, I had to change that. And it also contains the accounts and what they contain, and there I also had to change that. So yeah, in order to be able to use that, which that IDL is then used to create those things. So I needed to fix that. So anyway, we just use this internally now. So screw, this is now an internal thing. And I just store it as a U8. And when I print it, so I want my option back. So once again, I'm gonna implement for, and if it's anything else, then I will return none. So that's an option. It's none if it's anything else than 1 to 5. If it is 1 to 5, then I return the mood. So I can do stuff like maybe mood is mood from this new mood U8. And if my maybe mood is none, or let's do it the other way around. If it is some, then I can do that. Otherwise, I will say not a valid mood. And here I unwrap. If you don't know Rust, here we basically just get the mood out of this maybe mood. This is just for my internal thing. Here I have the actual mood then that it prints that. I could also print the U8, and storing I will just use the U8. But that's fine. The outside world will just need to know this mapping somehow. But it's fine. It's an acceptable example, I think. Okay, now we have this function that will set the mood, but we didn't discuss yet where that account comes from and what account we need to provide here for this to work. So we were here in the set mood. Here the methods should now have a dot set mood, and I can set the mood to 1. Well, actually I want to set it to 2 for it to be happy, because 1 is sad. Maybe 0 is sad. I'm not even sure. Sad is actually 0. So to actually match the actual numbers, let's do this. That's better than it matches the actual ones. So if I set it to 1 here, then it will be happy, and I want it to be happy. So yeah. Now accounts, the state. What does it put there if I don't do anything? I don't know. Let's test. State is not provided. Oh yeah, okay. So it doesn't put anything there. Okay, so we need to provide the state account. But what if I say, hey, just a user address here, use that as my state account? Guess what? That's not gonna work for many reasons. For one, it doesn't even have data. And secondly, it is owned by a different program than expected. And now we can finally talk about account ownership. A very important thing to understand when it comes to Solana development, since everything is an account and every account has an owner. It would be good if you understood what the owner really is. So this comes down to security. Yesterday we already saw that here in the account info owner. Every account has an owner. The address of the program this account has been assigned to. And in the Explorer it also says assigned program ID. So every account is assigned to a program, and that's what we call the owner. The owner is always a program, and that program has sole authority over that account. And what does that mean? It means that the owning program is the only one that can write to this account, the only one that can modify the state of that account. So in this case, if the account is assigned to the system program, then only the system program can change the state of the account, which is why we had to call the system program to do a transfer, because we wanted to change the Lamperts. Now there's one exception to this, and that is crediting Lamperts. Anyone can add Lamperts to any account, well, almost any account, if they're not read-only. But most accounts, if they're flagged as writable, you can add Lamperts there, but only the program who owns the account can reduce the Lamperts, debit Lamperts. Okay, so that's why ownership is so important. They call it assigned program ID because owner, the word is a bit confusing maybe. Because who really owns that account? Well, usually you think it's the person who owns those funds. In this case, it would be me, but no, the owner of the account, really in the technical sense, the assigned program ID would be the system program. Okay, so if we would query the owner here, then this would spit out the system program. This is the address of the system program. There you go. Okay, good. With that in mind, let's come back to here. So we need an account that my program owns. how do we get there? Well, per default, all of the accounts are owned by the system program. For instance, the one where we sent some sol to yesterday, per default, it's just owned by the system program. All of the accounts are owned by the system program until the system program changes the ownership, because the ownership is also just part of the account that the owning program can change. So if the program owns the account, it can change the owner. And therefore the system program also has instructions, specifically assign instruction would assign it to a different program, or the create account, that's what we usually use for a brand new account, that will put Lamperts on that account and then allocate some data and then assign it to a program. So we could either create a script that creates us an account, or we let the program do this. I'm going to show you both variants. And the first one with the kit with a get create account instruction. This thing takes the new account address. So now we need to know what is the account that we create. Either I would create a new key pair for the account, or I create a temporary key pair with a generate key pair signer. So I'll get the ephemeral key pairs address here for the new account. Oh wait, I need to sign so I don't put the address. The payer, this is the account that is funding that new account. I'm gonna say it's my key pair, because we need to pay for state on Solana. The space is how much data we want in bytes. I'm just gonna put the magic number of 9 here. Don't ask me why. I'm gonna maybe explain later. And Lamperts, that's now what we actually pay from the payer. And on Solana, you pay upfront. And if you delete the account, you can get that back again. And in order to find out what's the minimum I need to put on that account, there is this get minimum balance for rent exemption. And I just put the same size and await this, then that should be fine. And the program address, now that is the owner. Here I define who is owning this. So this will be my program, or I'm just gonna hardcode the address of our program. And then I will also log the address for this account, and then I'll quickly run this, create account. So here I'm creating this account. I can now check this on chain. It's an account that has 9 bytes in data, so much sol, because that's the minimum balance for being rent exempt. So that's basically what we pay for to keep that state. And it's owned by our program. Great. And now I can just put that account in here for our test. I'm gonna call it the state account. This would be the state account address, really. Oh yeah, you get it. And I set the mood, and that should work, I think. It does not. Ooh, yes. That is true. It's not the right type of account, because it's not written by the... Okay, never mind. Because we're using Anchor, it's already doing some checks on that account that now fail. So second way, we do it with our program. So in order for the account to then have the right type as well, Anchor is already doing some magic in the background. But that also means that we need to let Anchor create that account. We already have this initialize function that is not really initializing anything yet. So let's change that to also initialize the state account. So I'm gonna put the state account here as well. I will need to say that this account is actually mutable, such that we can change the state. The user will now also be mutable, because I will want that user to pay for that. And there's a quick way to do this. I can say init for that account, that Anchor creates this account basically, and I don't need init and mute at the same time, so just this. So it's a init, and then I need to tell it how big this account is and the space we need, and also that you just need to know once. We need 8 bytes plus the size of what we want to store. 8 bytes because Anchor does some magic, which you will learn in future videos. And I can also say derive some init space then I can tell this thing, the mood account. I know it's 1 byte. I can also say +1, but it would be nicer to use that. And then init also needs a payer. So the payer, that will be my user, because on Solana we need to pay for an account to exist. We basically pay for the state, and that's essentially just a deposit. We just need to put some lamperts on there as long as we want that state, and then we can remove them again when we don't need that state anymore. So we basically just say, hey, this account should pay for the initialization of this. And now we just also need to add the system program, because we learned all accounts are owned by the system program. So to change the ownership of a default account, of a new account, we need the system program. So that's just a program with the same lifetime, and it's the system program. There we go, then this works. And now here, can I say mood account init space? There we go. Then it calculates the space of this struct down here, but we still need to add 8 bytes because of an account discriminator. But don't worry too much about what that means. I don't want to dig too deep. Not yet. We'll get there. Okay, but like this, I just need to put that here. I don't need to do anything in my initialize instruction with that account. Just with those things that I wrote here, Anchor knows that it should create that account. Okay, I can say account created and write the key of this. Here that's a function? Okay, sure. Good. Should we test that? Let's build this, and then we see what we need to change in our script here, because now we will need to provide the state account. Otherwise, also this test will fail. Let's do anchor test just for fun. Yeah, now both of them will fail because trying to init payer as program account. You should not initialize the payer as a program account. Why is that happening? Because again, it just randomly puts in my wallet address for the state, which is not what we want. Here we just want a new account, and the problem is now I will also need to add this as a signer. So I'm afraid I will have to go with old school stuff. See, this is gonna get better in the new version of Anchor, where it's actually gonna use the kit. I think we still need to use the Web3.js to be compatible here. When we add signers, Anchor Web3 signers, yeah, it's in Web3. This is still using the old library. Anchor Web3 key pair. I create a new one. That's the old school way of doing things with a Web3.js. And then for the state here, I can say public key. So this gets me the address of this account. And then here I provide the state account as a signer. Actually, I'm not too worried about this. Like, if you don't understand what's happening here, that's fine. We'll go through it. Oh, actually, maybe I should do this outside here, because then down here, I will also use the state account pub key for this test. Okay, this should hopefully work now. I don't need to redeploy, but I do. There we go. 2 tests are passing. And again, I'm not too worried that you understand this, because that's the old way of doing things. This will get better with Anchor 1.0. What I'm interested in is showing you what those transactions did. We just had to find a way to call them, but now that's what happened. So we sent the first transaction to the initialize instruction of our Anchor program, and it got those 3 accounts. The first one was my signer, so that's the user. The second one, that's the state account. So that's the one that it created. And here it internally did a create account with the system program. That's a so-called CPI, a cross-program invocation. We will look more at that in 2 days or tomorrow. Let me check my curriculum. Oh yeah, actually tomorrow already. Yeah, tomorrow already we're gonna look at CPIs and PDAs and stuff. If that's words that you don't know yet, that's fine, because we'll look at it tomorrow. Anyway, so we created that account with 9 bytes. We put enough lamperts on there for it to be rent exempt, so we paid for the state. And that's it. Logged that it created this account. And then the second transaction that now called the set mood instruction, this one used the same account. So that's, we can say that's our state account. And it said new mood is now happy. Isn't that great? So in this account, we now stored that our mood is happy. That's wonderful. Our program is stateless, but by giving it an account as a parameter, it can use the state there. It can load and store variables there. So we could do a get mood where we don't put a new mood, but we just say from the account. So here I'm gonna get mood. So it's gonna be the same thing, except I don't need it as writable because I don't want to modify that. I'm not gonna put the mutable thing here. So this can be just a read-only account, but otherwise it's the same. And then here I just print our mood is, and then the mood of the account. So the context accounts state has a mood, which is a U8, but we still want the enum mood. So we will once again from U8 do this. Then we get an option and we will just unwrap because we made sure here that we just store valid moods. So there can't be anything invalid in here anyway. So this should never fail. I'm confident that I can just do that. And then it should print me my mood. Let's also add that as a test, get mood. And now I will ignore the first two things and I'll just hard code the state account address in here. And I will use this account that we created. Now I don't need to create it anymore. So I don't need a key pair anymore. I don't need the private key anymore. I just needed this to create that account with a system program, whatever, doesn't matter. We have that account now, so we can get mood that doesn't take any parameters. It does take the account, and here I just put in the account address. And if we deploy that program and then test it, there we go. We have a passing test. That's the signature. And if we look at that here, we see our mood is still happy. Woohoo! Happy! So we do have state with our program through that state account. We need the account to persist stuff. That's what I want you to take away from this. In order to store anything on Solana, it needs to be in an account. Also, programs. Even the program, what that is basically also just an account that holds some data like the upgrade authority, and then there's another account with the actual executable data. But those programs, they don't have state themselves. Like just the program doesn't have state. It requires additional accounts that are assigned to the program, that the program can actually persist stuff and have state. And all of the accounts make up the state of Solana. So when we talk about the state, we're talking about all of the accounts of Solana. That's the state, the current state. And the state changes. And state changes are part of the ledger. Ooh, is that confusing. But yeah, so we again see 9 bytes. That's our account. Great. Good. We can now set the mood to something else. I just use the same address again. And I set the mood to, I don't know, we're already bored. I'm getting bored here. I set the mood to bored. So transaction number 1 does the set mood instruction and the new mood is bored. And the second transaction does the get mood instruction and our mood is bored. Great. So we can change that account. And we can also look at the account itself. The Explorer here doesn't, or does it, anchor data? In order for that to work, we need to first deploy here manually, because then it will hopefully also upload the IDL on chain. Yep, then it writes the IDL. So that's what we said is this interface here for describing the accounts and stuff of the program, accounts and instructions. And if that's there, then hopefully, yes, look at that. The Explorer knows the account data of this thing. Oh, it's a mood account and the mood is 4. It doesn't know board because it doesn't have that thing, but it does have the right number here. And also now that we updated the IDL, if we go back to the transaction with the get mood, now it also says get mood here. That's why it's cool to upload the IDL on chain. And Anchor does that automatically if we say Anchor deploy. So here we see that we use the get mood, and in the transaction before that, we use the set mood with the new mood of 4. So that decodes it neatly for us. But really, and now we can already get a little bit more technical again. Really, this is our instruction. This is just a nice representation, but really that's what's happening behind the scenes. Every instruction, as we mentioned yesterday, contains the program, the accounts, and the instruction data. And I did mention something about the function name and the parameters, that is all the accounts and the real data. But let's look at that here in raw, and let's go through that a little bit. So let's have a bit more of a low level look at this. The program, that's obvious, that's our program, that's the program we call. Then the accounts, we just provided one account, we provided it as writable, because remember we said if we want to write to the account, then it needs to be flagged as writable in the transaction. So that's why this is here. So there's one account, and then there is the instruction data. And the instruction data secretly, without us really having to do anything about that, contains those 8 bytes, and they basically tell the Anchor program what function to call, so which instruction that is. That's the so-called instruction discriminator. In this case, 8 bytes to know which instruction to call. And after that, there's the actual instruction parameters that we put in, which is just this U8 of 4. The same thing also happens to the actual account. Again, Anchor neatly decodes that for us. But if we were to look at that account in raw, which I love to do sometimes, if you're watching my videos, I do that all the time, we see that's the account address, that's the owner, so it's assigned to this program. We ignore those things because they're not relevant anymore. And also here we have 8 bytes. Those are those secret 8 bytes that we had to add here. You just need to know that, because that is the so-called account discriminator, just so Anchor knows which type of account this is. And then comes the actual data that we defined in this account, which in this case is just a U8 for the mood. So that's just this 1 byte here. Currently, we're bored. But now we learned something, so we can be excited. Test this with skipping deploy. We don't need to always do that. And now, if I check that account again, now it's suddenly 3. Isn't that exciting? Because we changed the state to 3. Our mood is now excited. Nice, nice. Okay, we can do all of this and we can change the state of that account because the program that was called in this instruction is the owner of that account. That's why it can modify this account. So that's the concept of the account ownership. We also understand that even our program itself is an account that is itself stateless, but it is part of the Solana state because the program was written with a few transactions to this account. And what else did we want to learn today? We also learned that we need to pay for state. So we need to have Solana balance on an account for that account to exist. You can't just store indefinitely on chain. Also, that's quite expensive. They're going to lower the price of rent. But yeah, what I need you to understand is that it needs some sol in order to store data, and how much sol depends on how much data you want to store. But our Anchor did that automatically for us when we said init here. It knows the space, so it knows how much rent it needs to put there. That's all done by Anchor automatically. And like a lot of things are done by Anchor automatically. All of the deserialization and serialization and persisting that stuff. That's why Anchor is so helpful. We don't need to worry much. We just say, hey, the state is this, and it will write that there. So to get started writing your first program, Anchor is really nice. So as a homework, I encourage you to write your own first Anchor program. You can mainly copy what we did here, but come up with your own ideas. Maybe you want to build a counter, that's the classic example, that just counts up, not a mood, but a counter, or you want to store something else. Whatever comes to mind. But try it out, try if you can build and deploy an Anchor program, and then actually call the program as well through an instruction in a transaction. So send the transactions that contain the instructions to call the program. And there's still many things that we could improve in this program. For instance, the state account currently is just one random account. Tomorrow, we will learn how we could do that better with a PDA. This would then make sure that there's just one state account, because currently we just created one, but we could do another one. We could just initialize another state account. So instead of this account, I would now use this one again that was just newly created, and then I send those 3 transactions. There you go. We created a new one, and now we have a new state account where we get the mood, and we're once again excited. But really, let me change that to 2. Do it one more time. Really slowly, we're getting annoyed that we have so many different state accounts. Because now I already have 3 state accounts. Each of them has a different mood. If I wanted to make sure that there is just one single account for the program, I could use a PDA. But how we would do that, I'm gonna tell you tomorrow. But one thing that I still want to do with you today is explain what this is. This is what we're returning in each of our functions here, and it's a result. A result can either be okay for that was successful, or it can be an error. So in the case where we don't provide a valid mood, for instance, we could say error and then provide invalid instruction data, because the instruction data that we provided was not valid, and we could return that here. I could also drag that in here, and then I could do it like this, then it returns. That's just Rust. By the way, I do have a Rust basics tutorial as well if you don't understand what that is. So if we have the right mood, then we return okay, otherwise we return an error. Now what would that look like if we test this? Let's try and put in 10 here. Then the set mood would be failing with invalid instruction data, and the log would also say not a valid mood, because that's what we're writing here. So here that would make that transaction fail, and if I still force it to send that transaction, then we would see that the result is an error. It's not success anymore. So this is how we programmatically make an instruction fail. And it's always the program that makes the instruction fail, or the runtime. The runtime can also, for reasons, make the transaction fail. Anyway, so to make an instruction fail, this is how you would do it. Okay, so far so good. But then also, what's that in there? That might look a bit weird to you. So why is there an okay with those brackets, but then more brackets in there? Or braces, whatever you call them. This here is the unit in Rust. That's like void in C. It's like the nothing. So we return a result for a unit, nothing. We could return a result for a U8, and then we need to put a U8 here, for instance, our mood. Actually, get it from the state here. Now we have return data of our transaction as well. Let's try that. So the other one will still fail, but the get mood, this doesn't fail, and this is the transaction. If we look at this, nothing really changed in the get mood, except we now have a return value here. So the program returns this, and this, if you can read base 64, which obviously you can. I'll just quickly get myself a base 64 codec, and from this codec, encode, yes, it's encode, not decode. Don't think about it too much, otherwise your brain will hurt. And if we decode that, we get 3, because we are still excited that this works. We can return stuff as well in our transaction. So that's what this is. Great. So we heard about return values as well. We saw how we can fail a transaction. Good. This is still not the perfect program, obviously. We can still improve stuff, but it's good enough for now. I think we wrote a nice little program here. I'm happy with that. That showcases most of the basic things that you need for writing your Solana program. And obviously that's not all, but it's all for today. Yeah. So I hope that I see you again back here tomorrow. Today we deployed our first program. We learned about account ownership, which is a really important concept. And we did a little bit of program development with Anchor. And if that all seemed a bit like magic to you, then that's perfectly fine. Anchor is a bit like magic because it just does so many things for you that you don't have to bother with them. But it also means that you don't need to fully understand it to work with it. That's why I used it to start out. We did a quick Anchor program just to quickly get a program on chain. Don't you worry, we will get more into depth to really understand how programs work. We already teased it a little bit with instruction discriminators and the account discriminators. That's all handled by Anchor. On day 6, we will write our own program with Pinocchio, where we don't have all those conveniences that Anchor provides us. So don't worry, you will understand more with every day. So do make sure that you come back tomorrow to keep learning the basics of Solana development. Tomorrow, day 4, where we'll discuss more of the core concepts, PDAs, CPIs, and signers. That's gonna be good. I'll see you tomorrow.